SASE is a maturing market with many vendors claiming to deliver complete SASE capabilities. Evaluating them requires clarity on what you actually need and what each vendor actually delivers. Single vendor SASE versus best of breed integration is the first strategic decision. Single vendor platforms, Zscaler, Palo Alto Prisma, Cato Networks, provide fully integrated capabilities from one vendor. Best of breed means choosing the best SD-WAN, CASB, and ZTNA solutions independently and integrating them. Single vendor simplifies operations and provides better native integration. Best of breed may provide superior individual component capabilities. Evaluate the cloud-native nature of the solution. SASE should be delivered from a distributed cloud platform, many global points of presence, not from a small number of centralized data centers. The number, location, and performance of POPs matters significantly for your user's experience. Assess the ZTNA capabilities specifically. How does the solution handle application access? Can it integrate with your existing identity provider? Does it support both agent-based and agentless access for unmanaged devices? Evaluate data security capabilities. Does the CASB component provide sufficient visibility into your SaaS portfolio? Can it enforce DLP policies inline? Can it detect and block sensitive data exfiltration? Consider your cloud security integration requirements. Does the SASE solution integrate with AWS, Azure, and GCP security services? Can it forward security events to your SIM? The SASE platform should complement your cloud security architecture, not operate in isolation from it. So, let's start with a question that sounds simple. How good is your model? You'd say accuracy, right? 94%. Done. Let me break that. Imagine a fraud detection model. 1 in 1,000 transactions is fraudulent. I build you a model that says not fraud every single time. What's my accuracy? 99.9%. Best model you've ever seen. Catches nothing. So accuracy is meaningless on imbalanced data, and almost all interesting problems are imbalanced. Fine, you say. Use precision and recall. Better. But now you've got two numbers and they trade off against each other. Push recall up and precision falls. Which do you want? That's not a technical question. That's a values question. In fraud, a false positive annoys a customer. A false negative costs money. In cancer screening, a false positive causes anxiety and a biopsy. A false negative can be fatal. The metric can't tell you which matters more. You have to decide. And then there's the deeper problem. 94% on what? On your test set, which came from your historical data, which reflects the world as it was, not as it is. So here's my question for you. When your team quotes a performance number, do you ask what it was measured on? Because that's where the truth is hiding. So let's talk about confidence, because this is where people get badly misled. Your model returns an output and a confidence score. 97%. Feels reassuring. What does it actually mean? Here's the honest answer. It means the model's internal maths produce that number. It does not mean the model is right 97% of the time when it says 97%. That property is called calibration, and most models are not well calibrated out of the box. Deep networks are notoriously overconfident. So you can have a model that's confidently, fluently, articulately wrong. Sound familiar? That's exactly what a hallucinating language model does. It doesn't hedge. It doesn't say, I'm not sure about this citation. It states it with the same tone it uses for facts. Now here's the distinction that matters. There are two kinds of uncertainty. One comes from noise in the data, the irreducible randomness. You can't fix that with more data. The other comes from the model not knowing because it's never seen anything like this input before. That one you can fix, and it's the dangerous one, because that's the out-of-distribution case where models fail hardest and complain least. So the question I'd have you ask your data scientists, is our confidence score calibrated? Have you checked? And what does the model do when it sees something genuinely new? Usually, it guesses, confidently. Alright, this one is the most practically useful video in the chapter, so stay with me. Here's the scenario I have walked into more than once. A client says, "We think our model is drifting." "Good," I say, "show me the baseline." And they look at each other. They deployed 18 months ago. They never recorded what normal looked like. So now they have a number and no way to know whether it's bad because they don't know what it was. Think about it like health. Your doctor takes your blood pressure at every visit. Why? Not because one reading is meaningful, because the trend is. A reading that's high for you might be normal for someone else. Without your history, the number is nearly useless. Same with models. Your baseline should capture performance at launch, yes, but also more than that. The distribution of your inputs, the distribution of your outputs, performance broken down by subgroup, not just overall, latency, rate of human override. That last one is gold, by the way. When people start overriding more, something changed before your metrics noticed. And recorded properly, not in someone's notebook, in a system. So here's my ask. Go and find out whether your production models have baselines. If they don't, that's this quarter's work. Everything downstream depends on it. So here's a hard question. What's an acceptable error rate for your model? Go on, pick a number. Most people can't, and that's not a failure of nerve. It's because the question is genuinely difficult, and here's why. There's no external authority to tell you. In cybersecurity, you can point to a standard. In finance, you have capital requirements. In AI, mostly nothing. Somebody in your organization has to decide and own it. So how do you decide? Let me give you 3 anchors that actually help. First, the human baseline. What's the current error rate of the humans doing this job? Because that's your real comparison. If your loan officers are inconsistent and biased at some rate, a model that's better than that is an improvement, even though it's imperfect. People forget the counterfactual isn't perfection, it's the status quo. Second, the distribution of errors. A 5% error rate spread randomly is very different from 5% concentrated on one group. Same number, different world. Third, reversibility. We covered this. Permanent harm demands a tighter threshold than correctable harm. And here's the practical test. Whatever number you pick, write it down before you deploy. Because if you decide the threshold after you see the results, you'll pick whatever the results are. Everyone does. That's just human. So let me tell you why you cannot borrow someone else's thresholds, however tempting it is. Same model, 92% accurate. Let me put it in 3 places. Place 1, a retailer using it to recommend products. 92% is excellent. The 8% gets you a mildly irrelevant suggestion. Nobody's harmed, ship it. Place 2, a bank using it for credit decisions. Now that 8% is people denied credit wrongly. Is it acceptable? Depends entirely on who the 8% are, whether there's an appeal route, and whether the errors cluster. Place 3, a hospital using it for triage. 8% could be deaths. Suddenly, 92% is a scandal. Identical technology, identical metric, 3 completely different verdicts. So when a vendor tells you their model achieves state-of-the-art performance, the correct response is, in what context, for what decision, affecting whom? And here's the part that catches people out. Context changes even when your model doesn't. I saw a chatbot deployed for internal IT support. Worked well, low stakes. Then someone pointed it at customers. Same model, same accuracy, entirely different risk profile. Nobody reassessed because nothing technical had changed. So the trigger for reassessment isn't just model change, it's context change. Put that in your policy. So let's talk about the tension everyone pretends doesn't exist. Safety versus speed. You'll hear people say it's a false trade-off, that good governance makes you faster. And there's truth in that over the long run. But in the moment, on a Tuesday, When a team wants to ship and your review takes 3 weeks, that's a real trade-off, and pretending otherwise makes you sound naive to the people you need to influence. So let's be honest and then be smart about it. Here's what happens when governance is too heavy. Teams rout around you. They call it a pilot, they call it a prototype, they call it anything but AI. And now you have shadow AI, which is the worst outcome because it's unassessed and invisible. You didn't reduce risk, you hid it. And when governance is too light, something serious gets through. And then the pendulum swings so far the other way that nothing ships for a year. So the answer isn't a dial between fast and safe. It's triage. Make the low-risk path genuinely fast. A lightweight self-assessment, automatic approval, done in a day. And spend your rigor where the stakes are real. Here's my test for you. How long does it take to get approval for a genuinely trivial AI use case in your organization? If it's more than a few days, your teams are already going around you. So how do you actually prioritize? You've got 40 AI systems and resource for maybe 6. Where do you spend? The classic approach is a risk matrix. Likelihood on one axis, impact on the other, colors in the boxes. And I'll be honest, I have mixed feelings about these. The strength is real. They force a conversation. Two people arguing about whether something is medium or high are having a useful discussion. And the discussion is worth more than the box. The weakness is also real. They create false precision. Someone says likelihood is 3, impact is 4, so the risk is 12. But 3 of what? You multiplied 2 guesses and got a number that looks like maths. So how do I use them? As a conversation tool, not a calculator. And for AI, I'd weight the axes differently than tradition suggests. Start with impact on people, not likelihood. Because likelihood for AI is genuinely unknowable in a new system, and impact is at least imaginable. Then add a factor most matrices lack, reversibility, and another, scale. A model making 1,000 decisions a day amplifies any error 1,000-fold. So my simple heuristic, how many people, how badly, and can we take it back? That's cruder than a matrix, and it's usually more honest. So let's talk about money and people, because frameworks are free and implementing them isn't. Here's the pattern I see. An organization decides to do AI governance. They appoint someone, often part-time, often someone from privacy or security who already has a full job. And then they're surprised when 18 months later, there's a policy document and not much else. So let me give you the honest picture of where effort actually goes. The biggest cost isn't assessment, it's discovery. Just finding out what AI you have. I mentioned that client who couldn't tell me if they had 12 systems or 200. Working that out took months, and it was the single most valuable thing they did. The second biggest is monitoring. Not the initial review, the ongoing watch. Because AI risk isn't a gate you pass, it's a condition you maintain. And ongoing costs are exactly what nobody budgets for, because the business case was written around the launch. Third is capability. Your risk people don't understand models. Your model people don't understand risk. Somebody has to bridge that, and bridges take training. So here's the question I'd put to your sponsor. We funded building this AI. What have we funded for watching it for the next 5 years? Usually, the answer is silence. So let's finish this chapter with the hardest idea in it, the measurement gap. Here's the gap. You measure what you can measure. You care about something else. And the distance between those two things is where harm lives. Let me make it concrete. You care about fairness. Can you measure fairness? Not really. You can measure statistical parity or equalized odds or a dozen other definitions. And here's the thing that should unsettle you. Those definitions are mathematically incompatible. You cannot satisfy them all at once. It's been proven. So you pick one, and you've now defined fairness by which formula you chose. Same with explainability. You want to know why the model decided. You get a tool that produces feature importances. Is that why? Or is that a plausible story about why, generated after the fact? And NIST names this directly. AI systems can be inscrutable, not just complex, inscrutable. There may be no answer to retrieve. So, what do? You don't give up, but you hold your numbers loosely. You report what you measured and what it doesn't cover. You keep the caveat attached to the number. Because here's the failure mode: the measurement travels up to the board and the caveat gets lost in the deck. And then someone makes a decision on a number they don't understand. So let's gather this chapter up because it's the one that keeps you honest. First, every metric is a proxy. Accuracy is a proxy. Confidence is a proxy. Fairness scores are a proxy. Keep asking, a proxy for what and what does it miss? That question alone puts you ahead of most practitioners. Second, confidence scores are not probabilities of being right unless somebody checked. Ask whether your models are calibrated. Usually, nobody has. Third, baselines. If you don't know what normal looked like, you cannot detect drift. Go and check whether your production models have them. If they don't, start there. Fourth, you cannot borrow thresholds. Context determines acceptability, and context changes even when your model doesn't. Make context change a trigger for reassessment. Fifth, decide your threshold before you see the results. Otherwise, you'll pick the results. And sixth, the measurement gap is real. NIST says so plainly. Hold your numbers loosely and keep the caveat attached when the number travels upward. If you want a detailed, structured course on this topic with role plays, quizzes, and practice tests, our Udemy course link is in the description. Do subscribe to the channel if this is landing for you, and the playlist link is in the description too, giving you every video in the series in order. Next, we start on the 7 trustworthy characteristics. See you there.